Hello, everybody. Welcome back to Mathlete's Corner. Today, we are going to be discussing prime factorization, which is an area in number theory. So, before we start with any problems, let's just get a general idea for this topic. So, what is prime factorization? Well, every positive integer, you can split it up into the product of multiple primes. So, for example, we can write 12 as 2 times 2 times 3, or 2 squared times 3. Or you could write 15 as 3 times 5. Both of those are examples of prime factorization. Now, another important idea that stems from prime factorization is the number of divisors that a number has. So let's use these same examples, 12 and 15. How would we count the divisors of 12 just using the prime factorization? Well, every factor of 12 can only have prime factors 2 and 3. And say one factor of 12 is 2 to the power of m times 3 to the power of n. How can we constrain m and n? So how can we restrict the values of m and n? Well, m has to be less than or equal to 2, because otherwise this number cannot be a factor of 12. And similarly, n has to be less than or equal to 1. So the possible values of m are 0, 1, 2, and the possible values of n are 0 and 1. And then if you multiply 3 and 2, you get 6. And it turns out 12 does have 6 divisors. So we found an algorithm that's very important in math counts in AMC 8 to determine the number of factors for a number. So let's try this again with 15. So for 15, let's say the factor is 3 to the power of m times 5 to the power of n. So now we can say that m has to be less than or equal to 1 and n has to be less than or equal to 1. So now the values of m are 0 and 1, and the values of n can be also 0 and 1. So then you get 2 times 2, which gives 4 factors. So that's an important algorithm for finding the number of factors of a number. So let's get into a problem. So this is the 2022 State Sprint Problem 25. What is the greatest integer k such that 80 factorial is divisible by 45 to the power of k? So the first step here is to find the prime factorization of 45. Doing that, see that it's 3 squared times 5. Now, if we take this to the power of k, it becomes 3 to the 2k times 5 to the k. And we want this to be a factor. This symbol means that it's a factor of 80 factorial. So we want to find how many 3's and how many 5's can you get from 80 factorial so that we can find a bound on k. Well, what is 80 factorial? It's just 80 times 79 times 78, keep going, all the way up to 1. So from 1 to 80, there are 16 multiples of 5. So starting with the multiples of 5, there's 16 of those, but the multiples of 25 give us 2 factors of 5. So we have to add how many ever multiples of 25 there are, and that's 3. So we see that 80 factorial has 19 powers of 5. Now let's do the same thing with 3's. From 1 to 80, there are 26 multiples of 3. There are 8 multiples of 9. And there are 2 multiples of 27. And of course, there are no multiples of 81 and beyond. So adding those up gives 36. And now we can place our bounds on k. So from this, we get, remember, the power of 3 is 2k and the power of 5 is k. So we can say that k has to be less than or equal to 19 and 2k has to be less than or equal to 36. This one gives k is less than or equal to 18, which is a stronger bound And that's our final answer, 18. And on to the next one. This problem is also from the 2022 state sprint, but it's problem 27. So, if m and n are positive integers where m squared plus 14m minus 32 equals 3 to the power of n, what is the value of m plus n? So, this equation here is not very familiar. It's a nasty equation. So, let's clean that up a bit. So, we notice that on the left, we have a quadratic. And when we have a quadratic, the first thing we want to do is factor it. So after some experimentation, we'll see that we can factor it like this. And this is equal to 3 to the power of n. Now the key here is that m and n are positive integers. So that means that this is a positive integer, this is a positive integer, and of course, this is a positive integer. So because these two sides are equal, the only prime factor here is 3. In other words, both sides need to have the same prime factorization because they're the same number. So that means that this is a power of 3, and this is also a power of 3. So let's say that this is 3 to the power of a, and this is 3 to the power of b. Now we can say that 3 to the power of b minus 3 to the power of a is equal to whatever m plus 16 minus m minus 2 is. And obviously, those two numbers are 18 away from each other. So now all we want is two powers of 3 that are 18 away from each other. And after a little bit of time, it's easy to see that those two powers of 3 are 9 and 27. On the left-hand side, we get m plus 16 equals 27, and m minus 2 equals 9, and that gives m equals 8. And to double check, we see that both equations give the same solution for m. And the right side is 9 times 27, which is equal to 3 to the power of 5. So m is equal to 11, n is equal to 5. We can go back to our original question. It asks for m plus n. So we add up 11 and 5 to get our final answer of 16. Alright gang, that's all for this video. Thank you for watching. Don't forget to hit that like and subscribe button because we drop every Sunday. So we'll see you next time here at Mathlete's Corner.